Welcome to another video. Today we're going to talk about classes. Classes are user-defined data types, just like structures. The difference is that classes are more oriented towards object-oriented programming. Structures are not. To understand this better, let's just talk about a little bit of history of structures. Structures were defined in C language. When C++ evolved from C, structures were ported to C++, and but there was obviously a need for a hardcore object-oriented user-defined data type, and that's what classes are. User-defined data types that allow us an opportunity to overload operators, inherit classes, and things like that. These were not available with structures. So a class is defined using the class keyword versus the struct keyword that we use to define a structure. So I'm going to define a class called counter. This class basically will keep counters for me. So I'm going to have variables, multiple instances of this class to keep a counter. So the first thing I want to do here is mention here is that structures are by default public, but classes are by default private. So whatever I define here, for instance, my counter, so I'm going to call this counter type, and I'm going to call this counter. So this is my integer. This is by default private. If this was a structure, then this definition would make this integer public by default. But because this is a class, this is by default private. But after this, whatever I want to define as a public, I need a public method, for example, or a public data member. I need to have a member access identifier. So I have to identify whether it's a public or private. So anything that comes before this public identifier is private. So the first concept when we talk about classes pertains to constructors. So what are constructors? Constructors are the methods that are called when new objects of this class type are created. So the two properties of constructors are that they have the same name as the class, and they don't have a return type. So notice that there is no return type right here, and they have the same name as the class. Since this is a constructor with no arguments, we call it no argument or constructor or default constructor. Okay, so no argument constructor or a default constructor. So typically we use constructors to initialize variables. So I'm going to say counter equal to 0, and this is how this works. I declare a new variable of counter type, let's say my counter, and when I do this, the class object is created. Obviously memories, an integer variable is created, and this function is invoked by default. That's the purpose of a constructor. We can have more than one constructors in a class too. So counter type, but obviously we have to distinguish them somehow. So these are overloaded functions, and these are typically distinguished by the number of parameters like function overloading works. So here I will say counter equal to C. Let's call it with a more meaningful name. So value, counter equal to value. Now, when is this called, this constructor called, and when is this constructor called? I told you earlier, when you declare a variable of an object of this class, the default constructor is called. The default is called because I've not provided a value and I want to initialize this. But if I declare my second counter and provide an initial value, then in this case the second constructor is called. So second constructor is called. And in this particular case, the first one, default constructor is called. So with constructors out of the way, now we're going to write other methods of the class. So the first method I'm going to write is I'm going to allow the user to change the value for the counter. So I'm going to write called set value, and this will take in a value and simply put counter equal to that value. Now you can ask, why do I have two different functions performing the same thing? And your question is valid. The answer to that is that constructor is only called once. As soon as the object is created, constructor is called. It's never called again for that object. This function can be called as many times as I want for that particular object. So it's always good to give the user that opportunity to set a value if they want to set a value later on. Okay, so set value is one. So the counter functions, typically, what are counter functions? Increment, decrement. So I'm going to write a function called increment. Obviously increment just increments a value, so I'm just going to say counter plus plus. Interestingly, when we are working with when we're working with classes, you should always keep in mind that class is a user-defined data type, which means it holds data as well as functions on that data. So class holds data and functions that work on that data. So this is the data for this class, and these are the functions that work on this data. Okay, next up, I want to write a method called decrement, and as you would have guessed, this is counter minus minus, but I want to be a little smart here, so I don't want my counter to go below 0. So I'm just going to put an if statement here. I'm going to say if counter is greater than 0, only then in decrement, otherwise don't. So the minimum value that this counter will have will be 0. It will never go below 0. So this is a simple, neat class definition that we have. We have a counter type, we have a no argument constructor or a default constructor, we have a constructor with one parameter, then we have a set value function which we can use to set the value, and then we have an increment function and a decrement function. Let's write another function that returns the current value of the counter. So get count is this is a function that returns the count. Since it returns count, the return type is integer, and what this simply does is return counter. Okay, so these are all the functions. Okay, now a couple of things related to the public and private members of the class. So as you know, we have one private data member and we have all of these public methods. Okay, these are the methods that are in user control. So user can call these methods, but clearly a user cannot directly call a constructor. A constructor is called when you declare a new object. So when I say my counter dot, I see these four functions: decrement, get count, increment, set value. So let's start by, because my counter has a value 0 now, because the default constructor was called, this one. So let's go ahead and increment my counter. Increment, and let's increment it once again. So my counter dot increment once again, and let's see what the value of my counter is now. So see out, I'm going to say counter counter dot get count and a new line. Okay, let's run this. Oh, I forgot to put brackets with the function. So 2 increments, the value of the counter is 2. Pretty good. Next up, I'm going to say my counter dot decrement, and I'm going to copy paste this 3 times or maybe 4 times, and then try to see what the value of the counter is, just to make sure that my check that my counter doesn't go below 0 if it's working or not. So looks like it's working, it never goes below 0, and it will keep counting too. Let's use the set counter function. So my counter dot set value to 12, and so the data member which is inside the class is being used over and over again, and the class is holding that data and it's holding the functions that we perform on that data. Okay, so this was a very simple introduction to classes in C++. More videos will be coming soon, where we talk about separating the class definition, which is this part, and the function that uses that class, which is this part. We can separate this, and that actually is the purpose of writing classes, because then you can simply reuse that class as many times as you want in as many different functions as you want. So I hope this was useful. Let me just quickly run it again so that you can see the output. So I hope this was useful. Keep looking out for more videos, and if you like this video, please hit the like button and subscribe. Thank you very much.